The purpose of this video is to introduce and demonstrate a new method for solving quadratic equations. I'm going to do this by using this method to solve a typical quadratic equation. Now, traditionally, there were three main ways of solving an equation such as this. The first one was factorising or factoring. If the quadratic equation can be easily factored, then this is generally the simplest and quickest method to get to your results. If the equation cannot be factored, as is the case with this equation, then we have to go to other methods. The second one, of course, is the quadratic equation. This, I would generally recommend this one as being the most efficient way of solving most quadratics that aren't factorizable. However, some people may not like having to remember equations or to have to look them up each time they want to use them. So for those sort of people, there is a third option called completing the square. And this is the one which my method is challenging most strongly. Completing the square has a couple of issues for me. The first one is that you need to have x squared on its own. So you have to divide everything by the original coefficient of x squared. That means that in many cases you will be dealing with fractions from the very outset, which I would prefer to avoid if I can. The second issue is that when you've done the completing the square bit to match your required coefficients, it also throws out a third term which has to be kind of cancelled out to keep things balanced, and that I feel is a bit of a cause for errors. My method doesn't have either of those issues, so I tend to feel it's superior and keeps the numbers simpler for longer. So onto the new method. I'm calling this the difference of squares method, which, as you may guess, means it involves the difference of squares equation, which I'm showing here. Now, I'm presenting it the other way round. Normally it would be a squared minus b squared on the left hand side, so it would be the other way around. But I put it that way around because I want to get the left hand side of the quadratic into this form that is on the left hand side of this equation, i.e. the a plus b, a minus b form. And then I'd be able to go from there to the a squared minus b squared. Now, because this method does not require x squared to be on its own, we can scale the original quadratic to make the numbers easier and the technique easier to carry out. If we have a quadratic like this, for example, we can multiply the entire thing by 12, like this, to get everything on one line. That way we will keep fractions out as long as possible. Now, in a quadratic such as this one, the 2x squared plus 3x minus 4, there is a 3 in the x coefficient. Now, spoiler alert, this method will involve halving this term. For those people familiar with the quadratic equation and completing the square, this probably won't come as a great surprise. But again, to keep fractions out for as long as possible and keep it as simple as possible, it's a good idea to, again, double up on these. So that way the middle term is now 6x and can be halved quite easily. This would also apply with things like irrational coefficients. In this case, we've got a minus square root of 2x. Again, if we double everything, then again we have a coefficient of x which can easily be halved. This will even work for the generic equation. Again, by doubling it, we still have something that we can easily halve without going into fractions, and fractions can be held at bay for as long as possible, almost right to the end. So now we're going to jump into the method itself. So we start with our equation, And first thing I'm going to do is deduct 3 to move the constant across to the other side. Now I'm going to factor out an x from the left hand side, just like this. Now what I want the coefficient of x inside the bracket to be the same as the coefficient outside. At the moment you can see we've got 2x inside and x outside, but we can easily remedy that by multiplying by 2. Of course, if we do that, we also need to multiply the right hand side by 2, which of course gives us minus 6. Now, what I want now is this is a product which is looking similar to the form I want. But to get it actually in that form, I want to make a substitution in between the two values, right in the middle. So what I'm going to do is make a substitution of y equals 2x minus 2. As you can see, that is halfway between 2x and 2x minus 4. In practicality, it will always be the bit inside the brackets with the constant term halved. And this makes our equation now y plus 2, y minus 2 equals minus 6. So it is now in the form we want it. Again, there's no need to work this out. We know from the substitution that it's minus 2, so each product is 2 away from the midpoint, so it would be plus 2 minus 2. If it was 3x plus 4, then they'd be 4 away and they'd be y plus 4, y minus 4. Or you can have them either way around. It doesn't matter which way around the products are. It's still perfectly valid. So now we've got them in the correct form, we can use the difference of squares equation and we get y squared minus 2 squared equals minus 6. Which of course gives us that y squared equals 2 squared minus 6 is 4 minus 6, which of course is minus 2. So that means that y is now plus or minus, please don't forget the plus or minus, the square root of minus 2. Now minus 2 isn't an issue. This method deals with complex and imaginary numbers without an issue, and of course the square root of minus 2 is I square root of 2. So we can just plug that in and we have y equals plus or minus I root 2. So let's just carry this forward. Okay, now these are actually solutions to the original quadratic, but of course they're in terms of y and we want them in terms of x. So if you can recall, our substitution was y equals 2x minus 2. So now we need to get that in terms of x so we can get our solutions in terms of x. So again, that's relatively easy. Because we've got a positive value of x on its own on the right hand side, I generally find it easier to start by just swapping around the sides. Because we've got 2x minus 2 equals y. Of course, that gives us 2x equals 2 plus y. We can divide by 2 and get x equals 2 plus y over 2. Now, if your original quadratic had real coefficients, and if you used my tips to scale the quadratic to make the numbers easier, then this would be the first time that fractions become involved in this process. However, that's not a great issue now, as all we have to do is simplify the expression and then plug in our value of y, which of course is the plus or minus I root 2 over 2. And now, of course, the plus and minus bit gives us our two solutions, which are x equals 1 plus root 2 over 2i. Note I've just moved the I down out of the bracket to keep it in standard form. And of course the other solution is 1 minus root 2 over 2i. Now normally at this stage I'd bang on about checking your answers. There are two reasons for this. The first one, of course, is to make sure you haven't made a mistake somewhere in the calculations. And the second one is to make sure the method hasn't introduced any extraneous solutions. Now, I can tell you this method, all the steps are reversible, so this will not introduce any extraneous solutions. And any solutions you arrive at will be solutions of the original quadratic. In terms of checking your calculations, plugging these sort of results into the original quadratic could be a bit tricky, and quite frankly you're probably more likely to make a mistake doing that than you were actually calculating the results in the first place. So if you have a calculator available and can do it, then plug them in with that. Absolutely fine. If obviously for the calculator would need to be capable of complex numbers for this solution, but failing that, I would kind of recommend just carefully checking your work again, step by step, rather than actually trying to plug them manually into the equation and see if it equals 0. A final word of caution: if you intend to use this method in an examination of some sort, then it's perfectly valid unless the question asks for you to solve the quadratic equation in a particular way. But having said it's valid, please be aware that the person marking the paper may not be familiar with this method. So please make sure that all your steps are clear and don't skip any, so that they can clearly follow your work if they need to. Having said that, please feel free to play around with this and let me know what you think, and thanks for watching. Goodbye.